Alright guys, so we're going to work on solving by factoring today. So you need something to write with, a highlighter if you have one. We're going to go through a little bit of notes. So we've been factoring. The difference today is that we're going to have problems with equations. So our problem will be an equation, not expressions. So the problems we've been doing, where we've been factoring, have not had an equal sign. So today they're going to have an equal sign. So we will solve for x, or k or t, whatever the variable happens to be, and we'll go through it with an equal sign. So first thing is, when we're talking about this, we're talking about zeros, roots, and x-intercepts. So this is the vocabulary that we're going to see. These are all the answer. You can also come in here and add solutions, or solution, either way. They all mean what is the answer. What is the value of x? What is the value of k? What is the value of t? So we're looking at zeros, roots, x-intercepts, or solutions are all going to be the same word for what is the answer. Okay, so down here you have a box that tells you your process. This process is what we're going to use in order to solve these. The good thing is you already know how to do the majority of this because this is based on factoring. The important part, the thing that is new, is you have to set it equal to 0. Okay, so that means when you are solving a problem, if it is equal to 7, you would then have to subtract that 7 over to the other side, so that it was equal to 0, and then you're going to factor. So we're going to actually skip the bottom of this, and we're going to use this process on the next page. So here we have two problems that we're going to work. So let's start with example A. So it says solve 2t squared plus 8t equals 0. And if you're one of my kiddos, I told you that we're going to use a lowercase t a lot in this unit because t is one of the variables in an equation that we're going to use. So when you are writing, you need to be very careful because some of you have some handwriting that is not the clearest, easiest to read. That t, you should draw a curve on the t, on the bottom there, that little tail. And a plus sign should just be the little vertical and horizontal line. You need to be able to tell the difference. So what we're going to do is we're going to go through the steps that are on this page here. So first step is write the equation. We've already done that. Second step is set it equal to 0. So when I look at this, it is equal to 0. And then the second step is to factor it completely. So if I was to take this and ignore all of this, we're going to go through what we talked about with factoring. And step 1 of factoring is always to factor out the thing they have in common, that greatest common monomial. So I look at both of them. I have a t and a 2, so I can factor out 2t. And this is my undistribution step, so I'm undistributing that 2t. I am factoring out the 2t. So 2t times what would be 2t squared? Well, it's just t. And then 2t times what is 8t? It is 4. And you bring down the equal sign and the 0. So now what we're going to do, the next step on this page says to set each factor equal to 0 and solve. What this says is that I have something here being multiplied by something to get 0. Well, if I'm going to multiply to get a product of 0, something has to be 0. So either this right here has got to be 0, or this right here has got to be 0, or they both have to be 0. So what I can do is I can take that factor and write 2t equals 0. And I can take this factor and write t plus 4 equals 0. And I can solve them. So this is taking it down from what we call, or up from what we call a quadratic, down here to linear factors. These are just linear problems. We can solve for t in a problem like this. Up here at the top where we have t squared and then we have t, we can't solve for that. Not yet, at least. We can later. But this is one way of doing it. We can break it into linear factors because we have factored it down, and we can set these equal to 0. Well, here I would divide both sides by 2, and I would have 0 over 2 equals 0, so t is 0. And then over here, I would subtract 4 on both sides, so it will cancel, and I have t equals negative 4. So that's my answers to the problem. T equals 0 and t equals negative 4. So what happens is when we go to graph something like this, we're going to be graphing a quadratic, a curve. So if I was to look at this on a graph, it's going to look something like this. It's going to cross that x-axis at 0, and it's going to cross the x-axis at negative 4. It has two solutions. And if I come back here, I can substitute in at the top and put in a 0 here. I will end up with 0. And then same thing here, when I put in that negative 4 and substitute in, I will end up back at 0. So I've got the value of t that would give me that solution here, or that equals 0. Okay, so we're going to try one more. So it is solve, and it is negative 15x squared plus 21x equals negative 18. So we're going to start with our process. It says to set it equal to 0. That's going to be a really big deal here. Must equal 0. Okay, so first thing I need to do is I need to move that 18 over. So I would add 18 to both sides. So negative 15x squared plus 21x plus 18 equals 0. Now, if I was to ignore all of this, I just have a factoring problem, and that is my next job. Now that it is equal to 0, I am going to factor. And I start with my factoring. Step 1 is always to take out what they have in common. It is also leading with a negative, so I need to take that out. All of these are divisible by 3. So I can factor out that negative 3 or undistribute that negative 3. So negative 3 times 5x squared would give me my first term. Now I need to get 21x, so I would do minus 7x. And then negative 3 times negative 6 is my 18. You can just go ahead and write the equals 0 there. Now I'm going to factor. So I've taken out the greatest common monomial. We have nothing, it's not two terms, so step 2 won't work. Step 3, ask if they are perfect squares here, and they're not. So we're just going to go with our regular step 4 factoring. So I can come down here. Some people like to just rewrite this part and just deal with this part, so you're ignoring all this other stuff. You don't have to. It's kind of up to you. I'm going to multiply a and c, so it's 5 times negative 6, which gets me negative 30. So my factors of 30 are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Because I have a negative product, I have to have one negative number and one positive number. And they have to add up to give me that negative 7. So I'm going to go with this right here. Positive 3 and negative 10. So 3 times negative 10 is negative 30. 3 plus negative 10 is negative 7. So I'm going to break that down. I'm going to split that middle term. So 5x squared. I tend to like to write my negative term first. I think it's easier to factor. So I'm going to write my negative 10x first. You do not have to. You can go ahead and switch them and put them the other way. I'm going to come in and I am going to group them. This is my associative property, so I'm not changing anything here. I'm going to take out what they have in common. So the first pair has a 5x. That leaves me with x minus 2. The second set has a 3, which also leaves me with x minus 2. And remember that if these two binomials here do not match up, then you have factored incorrectly, or you have written the wrong equation, something, but you've messed up, so you got to go back. So I can say, well, these both have an x minus 2, so I'm going to factor that out. I still have to multiply x minus 2 by that 5x in order to get this part here, and then I have to multiply it by a 3 in order to get that part there. And then this dude up here this negative 3 that I factored out has to come back down here in the front. And it's still equal to 0. So this is what we've been working on. It's just we haven't had this equal to 0 part here. Now with the equal to 0, we can say, okay, well, we can set each of these factors equal to 0. So I've got this here, and this here. Well, negative 3 equal to 0. There's not even a variable there. They're not equal. It's not relevant to what we're doing. I can do the next one. X minus 2 equals 0. I would then add 2 to both sides. So I get that x equals 2. And then I take that third one, 5x plus 3 equals 0. I can subtract 3. So 5x is negative 3. And then divide by 5. So x is negative 3/5. So this has the two solutions here, x equals 2 and x equals negative 3/5. And then again, you can go back and substitute into the beginning. You should get a true statement with both of those. But having that equal sign causes me now to be able to solve and get a value for x or whatever the variable happens to be. Along with this part of the unit, we're going to do some word problems that use a special formula. So on the next page of your notes, we have what is called the vertical motion or projectile motion model. This is just an equation. This equation is not on your reference chart, so you have to know it. And it's going to look scary, but it's really not. Once you use it, it's going to be really easy to remember. So it's h equals negative 16t squared plus vt plus s. H equals negative 16t squared plus vt plus s. So this is our vertical motion model, and this is what I was talking about, how we're going to use that lowercase t a lot. That lowercase t is our time in seconds, okay? So this vertical motion model is talking about anything that we throw, we kick, something jumping, possibly flying, dropping, all those kinds of things. So this is for something that has a vertical motion. So a ball flying through the air, you know, something being dropped out of a bird's mouth as it's flying, those types of things. So the t is our time in seconds. The v is the velocity. So basically the speed, it's feet per second. So how fast is that ball going? Is it going 20 feet per second? Is it going 2 feet per second? That's velocity. The s is the starting height, which is also in feet. So where did the ball start from? Did you kick it from the ground? Was it, you know, in someone's hand when they threw it? Where was it? And then the ending height is h, which is also in feet. This is where that object ended, where it stopped. So was the ball caught in the air? Did the ball land on the ground? Did someone drop something, you know, off the roof of the house and someone caught it? Or was it landing on the ground? Those types of things. So down underneath that, it talks about what we use this for. So we use this for something flying through the air. An paper airplane flying through the air. Something being thrown, so throwing, someone throwing a football, a baseball. Someone could be kicking, something like a soccer ball. A frog could be leaping off of a lily pad. Something could be dropping. You could drop a paintbrush off of a ladder. Something could be jumping, so a cricket could be jumping, etc., etc., etc. Alright, so that last thing is when an object is dropped, the velocity is 0. Okay, so velocity is talking about the speed, the force behind something, so that when we drop that something, the velocity is going to be 0. And that'll be really important as we start working through these questions. But if something is dropped, if I just take this highlighter and drop it, I didn't put any force on it, I didn't push it anywhere, I just dropped it, it has no velocity. That velocity is 0. So we're going to finish the rest of these notes the next time that you're in class. So we will stop right here and pick up later.